Hello YouTube. In this video we're going to take a look at counterpossibles. A counterpossible is a counterfactual whose antecedent is impossible. So a counterfactual is a statement of the form, if P had been the case, Q would have been the case. For instance, if I had dropped the glass, it would have shattered. Right? We state a counterfactual in order to talk about what would have happened had a different event occurred. We have a counterpossible when the antecedent P describes an impossible situation. So, for instance, if Hobbes had squared the circle, children in Africa at the time would have cared. If I were the number 3, I would be an abstract object. If water molecules consisted of 6 carbon atoms, the moon would be made of cheese. If there were true contradictions, paraconsistent logic would be correct. Most philosophers would regard at least some of those counterfactuals that I just stated as having impossible antecedents. It is impossible to square the circle. It is impossible for a person to be a number, and so on. So these are counterpossibles. Now, the orthodox view of counterpossibles is vacuousm, which says that all counterpossibles are vacuously true. This comes from the orthodox view of the semantics of counterfactuals. So essentially the idea is this. With a counterfactual, so if P had been, then Q would have been, we evaluate this by taking the closest possible worlds at which P is the case, and then we ask whether Q is the case at those worlds. So with the counterfactual, if I had dropped the glass, then it would have shattered, we take the closest possible worlds at which I do drop the glass, and then we see whether the glass shatters in those worlds. So suppose that in the actual world, I'm carrying a glass about 5 foot from a concrete floor, and I successfully carry it to the table. Well, we now have to look at those worlds where, the environment is the same, where the laws of nature are the same, where I'm carrying a glass about 5 foot from a concrete floor, but where I drop the glass. And in those worlds, the glass does indeed shatter. So basically, when we look at a counterfactual, we make whatever is the most minimal change required to verify the antecedent, and then we see whether the consequent obtains following this. So, we look at those worlds that are just like our world, but where the glass is dropped. We disregard those worlds where the floor is made of cotton, or where the laws of nature are such that the glass is much stronger, or whatever. I mean, there are plenty of worlds where I drop the glass and it doesn't shatter, but those worlds are not among the closest worlds where I drop the glass, so they're not relevant to the assessment of the counterfactual. Now, exactly what makes one world closer than another is a very tricky question about which much has been written. There are many different ways we might assess the similarity of different possible worlds, but we don't really need to get into that here, because regardless of what criteria we use to judge closeness, we're going to get the same answer when we apply this framework to counterpossibles. So let's take if P had been, Q would have been, right? We're saying that if P had been, Q would have been. That's true just in case the closest P worlds are Q worlds. But if P is impossible, there are no P worlds. So this counterfactual is vacuously true. When there are no P worlds, anything is true at all P worlds. Similarly, there are no elephants in my room, so it is vacuously true that all elephants in my room are pink, and all elephants in my room are blue, and all elephants in my room are whatever you like. All of those statements would come out as being vacuously true. What makes these statements true is that they have no counterexample. So with the statement, all elephants in my room are pink, that would be falsified by a non-pink elephant in my room. There is no elephant in my room that fails to be pink, because there is no elephant in my room. So the statement, all elephants in my room are pink, comes out as vacuously true. All counterpossibles are going to be vacuously true for the same reason. So if P had been, Q would have been, that would be falsified by a P world that is not a Q world, by a world where P obtains and then Q does not obtain. So it's going to be vacuously true when P is impossible, because if P is impossible, there are no P worlds that fail to be Q worlds. So there is no counterexample to the statement. So, according to vacuousm, then, all counterpossibles are vacuously true. Where P is impossible, all statements of the form, if P had been, Q would have been, are just trivially true. By contrast, non-vacuists hold that some counterpossibles are true and some counterpossibles are false, and of the counterpossibles that are true, some are non-vacuously true. So, according to the non-vacuist, there are some counterpossibles that are non-trivial. Now, vacuism is fairly counterintuitive, I think. So, to see this, just compare these two counterpossibles. If Hobbes had squared the circle, children in Africa at the time would have cared. If Hobbes had squared the circle, children in Africa at the time would not have cared. I mean, we want to say something like this. It just seems obvious that the mathematical proofs produced by Thomas Hobbes made no difference to children in Africa at the time. Children in Africa at the time had no idea what Hobbes was doing. And even if they did have any idea what he was doing, they probably cared about other things. So, we're inclined to say that this first counterpossible is false. It's false that if Hobbes had squared the circle, children in Africa at the time would have cared. By contrast, the second counterpossible is true. If Hobbes had squared the circle, children in Africa at the time would not have cared. That's true, and it's not trivial. More broadly, it seems clear that these two counterpossibles are genuine alternatives. That when I assert one of them, I deny what is in the other. These two positions, these two statements are inconsistent. But if vacuism is right, they're not genuine alternatives. Both of them are true. So vacuists are probably going to agree that vacuism is indeed counterintuitive in this sense. Counterpossibles do seem to be non-trivial, but we can explain this non-triviality, this apparent non-triviality, by appealing to pragmatics. Also, you should see my video on the material conditional for more on pragmatic accounts of conditionals more generally. But anyway, one idea, so this comes from Timothy Williamson, is that we are misled about counterpossibles due to applying useful but fallible heuristics. So ordinarily, when evaluating a counterfactual, we use what Williams calls the suppositional procedure. So, with if P had been, Q would have been, when we consider this, well, first of all, we make the supposition that P, then if within this supposition of P we find ourselves accepting Q, we endorse the conditional. If P had been, Q would have been. Or if within the supposition of P we find ourselves rejecting Q, we reject it. We reject the whole counterfactual. This suppositional procedure is perfectly fine as a heuristic, but Williams says there are many contexts in which it's misleading, in which we would not want to apply a procedure like this. So consider, for instance, a mathematical proof by reductio. Let's say, for instance, we take the proof that there is no largest prime number. So we start by supposing that there is a largest prime number. We start by supposing that P is the largest prime number. And then within that supposition, we can deduce a contradiction. So if you take the product of all prime numbers that are smaller than or equal to P plus 1, so take that number, we can deduce within the supposition that P is the largest prime number that this product of all prime numbers smaller than or equal to P plus 1, that's both prime and composite. Now, still supposing that P is the largest prime number, we of course reject this as absurd. A number cannot be both prime and composite. Yet, we don't reject the counterfactual. If P is the largest prime, this other number is both prime and composite. We accept this counterfactual. This counterfactual is what tells us that there cannot be a largest prime. So this shows that this suppositional procedure is not going to be something we want to accept across the board, but in many cases it's hard to resist. So now suppose we have a situation where two statements Q and R are inconsistent. Well, normally at least we're going to continue to judge Q and R to be inconsistent even when we're evaluating them under the supposition that P. This fact, together with the suppositional procedure, leads to a heuristic along the following lines. Supposing that Q and R are inconsistent, we treat if P had been, Q would have been, and if P had been, R would have been, as inconsistent, right? So Q is not consistent with R, so if we accept if P had been, Q would have been, we must reject if P had been, R would have been, and vice versa. Now this heuristic works in most cases, but it leads us astray when P is impossible. Provided that P is possible, maybe this heuristic is perfectly fine. But in cases where P is impossible, this leads us astray. I mean, in the Hobbes case, here's what happens. We make the supposition that Hobbes squares the circle, we hold fixed various facts about politics, geography, society, trade, and so on. Given those facts, in general, children in Africa do not care about results from Hobbes's mathematical activity, so, we're inclined to say, oh yeah, within the supposition, children in Africa do not care. And that's clearly inconsistent with the statement, children in Africa do care, so we end up accepting one of the counterpossibles and rejecting the other. So, I mean, this sort of idea maybe explains why we judge certain counterpossibles to have non-vacuous truth values. It doesn't in itself explain why we have such strong inclinations to assign a specific truth value. I mean, obviously in the case of our Hobbes counterpossibles, it's not just that they appear to be inconsistent, it's that there's one of them in particular that we want to say is false and one of them in particular that we want to say is true. This heuristic, this fallible heuristic, in itself is only going to lead to the judgment of inconsistency. Another mechanism that the vacuist can appeal to here is H.P. Grice's conversational implicature. So essentially, the idea is that a speaker can imply or suggest something with a statement without explicitly asserting it. There's a difference between the literal content of a statement and then what it is used to imply in some specific context of use. Suppose, for example, that we are engaged in a heated argument about politics. In a fit of anger, I point and I shout, "There's the door!" Now, what I've actually asserted here is a proposition about the location of the door, but this isn't the only thing that I've communicated. What I'm really doing here is telling you to leave the room. So in this context, the statement, "There's the door," conversationally implicates something such as, "You should leave the room." Now, conversational implicature arises because when people communicate, they expect each other to conform to certain conversational maxims. And when a person's statement taken literally violates these maxims in an obvious way, their audience will search for other interpretations beyond the literal interpretation. So these maxims will include things like, give as much information as required, do not give more information than is required, be truthful, be relevant, avoid ambiguity, be concise. So consider again our heated argument, debating politics. I become angry and I shout, "There's the door." Now, taken literally, that's just completely irrelevant to the conversation. The location of the door in the room has nothing to do with one's assessment of different political parties. If I intended to communicate only the literal meaning of that sentence, if what I was intending to do was tell you the location of a door, I would be in flagrant violation of the maxim of relevance. So, of course, you search for an alternative interpretation. A door is the usual means of entering or leaving a room. If a person is angry with you, they will often want you to leave their presence, so you can infer from the context that I'm telling you to leave the room. Now, maybe counterpossibles work in a similar sort of way. So when I say a counterpossible like the Hobbes counterpossible, right, if Hobbes had squared the circle, children in Africa at the time would not have cared. Well, although this is vacuous, there are still some contexts in which it's appropriate to assert it, and it can still be used to communicate non-trivial information. So when I utter this statement, perhaps what I'm claiming, perhaps what I'm communicating is the causal claim that Hobbes's mathematical activity had no influence on the children of Africa at the time, and there was no obvious means by which it could have done. Even if Hobbes had proved a brilliant mathematical result, they would not have known about it. So for rhetorical effect, I propose a scenario where Hobbes does something outright impossible. Even this would not have made its way to the children of Africa. But, I mean, we can't really consider a scenario in which Hobbes squares the circle. There is no world where that happens. When we are presented with this counterpossible, then, we see that we need to do something different, right? Instead, then, we use this counterpossible to communicate something true about our world, say the causal relations between Hobbes's society and African societies. Now, this point brings us to another strategy for the vacuist, which is to question whether our intuitions about these counterpossibles are as they seem, right? So initially, when we consider the Hobbes counterpossible, we might think that we are considering a scenario in which Hobbes squares the circle. But is that really what we're doing? Well, notice that when we think about this counterpossible, the impossibility of the antecedent doesn't really play any role in our initial thoughts, at least. So when I say to you, if Hobbes had squared the circle, children in Africa at the time would not have cared. Right? What is it that you actually think? I mean, so you think about Hobbes squaring the circle, but what's the content of that in your mind? Probably you're just imagining Hobbes working in his room, right? Writing some stuff in his books. He's got some mathematical symbols. I mean, the actual content of his mathematical inquiries isn't going to be important. So really, what we're doing is we're thinking about Hobbes, we're thinking about his activities. We're not really thinking about mathematical impossibilities. If instead I'd said the counterfactual, if Hobbes had proved Fermat's last theorem, children in Africa would not have cared. Well, you're probably going to think basically the same way about that, right? When I imagine Hobbes proving Fermat's last theorem, or I imagine Hobbes squaring the circle, I imagine basically the same thing. Again, it's just Hobbes in his room doing some mathematics. So what is it? So when we judge that, one of these Hobbes counterpossibles is true and one of these Hobbes counterpossibles is false, what is it that you're really making a judgment about? I mean, you're probably not trying to conceive in detail of a situation in which genuinely squaring the circle occurs. You're just thinking vaguely about Hobbes doing some mathematics. So you're not really thinking about the counterpossible. And of course, this fits with the Gricean account, right? The counterpossible is just a tool that's used to implicate some other information, and that other information is what we feel confident asserting. So Timothy Williamson argues that in many cases, when we actually try to consider in detail a counterpossible, taken literally, we're going to lose the intuition that it must be non-trivial. So, for example, suppose I take a quiz which contains the question 5 plus 7 equals what? And then I write down the number 12, right? So I've given the right answer. Now consider the following counterpossible. If 5 plus 7 had been equal to 13, my answer would have been correct. Well, I think initially, right, our initial reaction to that is, well, that's false. After all, the answer I gave was 12, right? But if 5 plus 7 had been equal to 13, the correct answer would have been 13. So my answer would have been wrong. So if 5 plus 7 had been equal to 13, my answer would not have been correct. Therefore, we want to say that counterfactual is clearly false. So that's the initial intuitive reaction to this this counterpossible. But Williamson says, wait a second, consider this in more detail. What would things be like if 5 plus 7 were equal to 13? Well, presumably, if 5 plus 7 had been 13, then 5 plus 6 would have been 12, right? And then if 5 plus 6 had been 12, 5 plus 5 would have been 11, and so on. And we can keep applying that reasoning over and over again until we reach the conclusion that 0 plus 0 would have been equal to 1, which just means that 0 would be equal to 1. Okay, so we're supposing then that I do not give a correct answer to the question. Right? If 5 plus 7 had been equal to 13, and I had given the answer 12, then my answer would not have been correct, which means that the number of correct answers I give is 0. But we've just seen, it follows from our counterfactual supposition that 0 is equal to 1. So it follows that since the number of correct answers I give is 0, and since 0 is equal to 1, the number of correct answers I give is 1. So actually, this counterfactual that we initially thought was false comes out true. If 5 plus 7 had been equal to 13, the number of correct answers I give is 1, so I give a correct answer. Actually, and when you think about it like this, when you reason it out like this, there's not really even the intuition that this, so initially we encountered this counterpossible and it kind of seemed like, oh yeah, that's false. That's clearly false. But then we reason it out and we see, no, actually that seems like maybe it's true. Of course, we might object to this argument in one way or another, but the point is that the conclusion that Williamson arrives at here is not obviously crazy, right? And so the intuition that the counterpossible is obviously false is thereby undermined. In fact, when we consider the counterpossible, right, if 5 plus 7 had been equal to 13, my answer would have been correct. What's really going on is, right, we're not really considering a situation where 5 plus 7 is equal to 13, not 12. We're just considering a situation where the correct answer to the quiz question is 13 rather than 12. And that, of course, is entirely possible. It's entirely possible to write a quiz where the correct answer is 13 rather than 12. And we see that in that situation, if we hold fixed my actual answer of 12, then my answer is incorrect. That is what inclines us to judge the counterpossible to be false. But if instead we focus on this mathematical impossibility and try to elaborate on it, it no longer seems that the counterpossible is false. Now, if I were Bertrand Russell, I wouldn't need to beg for money on YouTube, but I'm not. I'm Kane Baker, and and I'm not particularly wealthy, and these videos do take a lot of time. So, if you want to support the channel, you can sign up to my Patreon. I have a bunch of bonus videos on there, so there's something in it for you as well. Or you can just send a one-off donation on PayPal. I really appreciate any of the help you can give. I offer private tutoring in philosophy. I have a degree, master's and PhD, so that's my background. Send me an email if you want to set that up. And I have a Discord. Links to all of this will be in the description. Additionally, of course, if you can't do any of that, well, leave the video a like, leave it a comment. That helps, that helps get it visibility on YouTube. So any kind of engagement is useful. All right then, let's get back to counterpossibles. So let's turn to non-vacuism. Non-vacuists say that some counterpossibles are not trivial. As we've seen, non-vacuists can appeal to our linguistic intuitions. There are a variety of counterpossibles that don't seem to be trivial, but linguistic intuitions can be misleading, and vacuists can appeal to mechanisms like heuristics and implicature to explain those intuitions. So, there are, however, other reasons for taking non-vacuism seriously. One argument is that many debates in philosophy presuppose non-vacuism. And this is because many philosophical debates concern theses that, if true, are necessarily true. For instance, it's generally agreed that if abstract objects exist, they necessarily exist. Or if God exists, God necessarily exists. Or if objective moral properties exist, they necessarily exist. So suppose then that I believe that abstract objects necessarily exist. I may well try to argue that my opponent's position entails problematic consequences. So I'm going to argue, if there were no abstract objects, then blah, 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 blah. Now, as I see it, this antecedent will be impossible. But in drawing out the consequences of this impossible antecedent, I'm not going to argue as if just anything follows, right? I'm not going to think, it won't be legitimate for me to say, well, if there were no abstract objects, then the moon would be made of cheese. That's just not a good objection, right? Even by my own lights, that's not a good objection. No, even though I think that the antecedent here is impossible, I still think that there are certain specific things that would follow if there were no abstract objects, and certain specific things that would not follow. Or consider this example. So this is from Francesco Berto and Mark Jago. So if intuitionism were true, much of standard mathematics would be lost. Suppose that we are not intuitionists. Well, then the antecedent here describes what we regard as an impossible situation. But we might well want to make this argument against the intuitionists. What we have here, if vacuism is right, is just a vacuous truth. For the same reason, it would also be true to say that if intuitionism were true, much of standard mathematics would not be lost. But it's, again, in the context of giving these philosophical arguments, we want to assert that first counterpossible and not the second. Of course, there's nothing nothing really challenging about, alternative logics like intuitionism, so long as we understand them as merely formal systems. I mean, there's no dispute that there are intuitionist logics and various other non-classical logics. Depending on, so describing how these formal systems work does not require thinking about impossible situations, but we can also reason about such logics where they're intended as claims about the consequence relation, about what follows from what. So everybody accepts that, yes, there is a formal system in which double negation elimination fails, so that some propositions of the form not P do not entail P. It's much more controversial whether it is in fact the case that, P does not follow from not P, that there are true propositions of the form not P, but no true propositions of the form P, right? It's, as far as most philosophers are concerned, here we're dealing with an impossibility. So if intuitionism is false, it's necessarily false, but we're perfectly capable of reasoning about what would be true if intuitionism were true, and this plays an important role in the philosophical arguments concerning intuitionism. So the idea is that within these sorts of philosophical debates, we're presupposing non-vacuism. Another important role for counterpossibles concerns causation by omission. It seems plausible that absences or omissions can have causal consequences. For instance, suppose I go on holiday for several weeks, fail to water my plants, and as a result, the plants die. It's plausible that my failure to water the plants causes the plants to die. Notice, however, that we're not remotely inclined to say that Frank Zappa's failure to water my plants causes the plants to die. What is it that explains this difference? Why is my failure to water the plants causally responsible for the death of the plants, while Frank Zappa's failure to water the plants is not? Well, here's one explanation for this from Sarah Bernstein. There are very close worlds in which I do water my plants, and in those worlds in which I water my plants, the plants live. By contrast, there is no very close world in which Frank Zappa waters my plants. A world in which Frank Zappa waters my plants would feature much more significant differences than a world in which I water my plants. In particular, those differences are of a kind that are not salient to me in my everyday life. Right? So in my everyday life, I'm going to weigh scenarios where I'm going to be at home, but I'm not going to consider scenarios where Frank Zappa comes back to life and comes to my home. So we have, like, both counterfactuals here are true, right? If I had watered my plants, they would have lived. If Frank Zappa had watered my plants, they would have lived, right? Both of those are true, but there are much closer worlds that satisfy the antecedent of the first counterfactual than that satisfy the antecedent of the second. So Alex Korucek, in his article on Counterpossibles, argues that, if there is such a thing as omissive causation like this, it naturally extends to impossible omissions. So suppose that when Hobbes was attempting to square the circle, there had been a prize for successfully squaring the circle, which Hobbes was aiming to achieve. Well, then it's natural to say that Hobbes's failure to square the circle is part of what caused the prize to go unclaimed. On the other hand, we're not inclined to say that Frank Zappa's failure to square the circle caused the prize to go unclaimed. And so we can apply Bernstein's analysis to these sorts of cases. There is a relatively close impossible world in which Hobbes squares the circle, right? In that world, Hobbes claims the prize, so the prize does not go unclaimed. By contrast, the impossible world in which Frank Zappa squares the circle is much more distant. Moreover, there's no particular reason to expect that the prize set up in Hobbes's day would still be available in Zappa's day, unless we make the additional assumption that Frank Zappa was born several hundred years earlier, which again would make this world even more distant from ours. So we can say, look, we have two counterpossibles that are both non-vacuously true, right? If Hobbes had squared the circle, he would have claimed the prize. If Zappa had squared the circle, he would have claimed the prize, at least assuming that Zappa was, doing this at the same time that Hobbes was. But there's, we take a relatively close impossible world, right? There's a relatively close impossible world in which Hobbes squares the circle at the time the prize is offered, whereas that's not the case for when Zappa squares the circle. This analysis requires non-vacuism. According to vacuism, yes, it's true that if Hobbes had squared the circle, he would have claimed the prize. It's also true that if Hobbes had squared the circle, he would not have claimed the prize. So, so yeah, this sort of idea of causation by impossible omission requires non-vacuism. Third, it has been argued that counterpossibles play an important role in scientific theorizing. This comes from Peter Tan in his article Counterpossible Non-Vacuity in Scientific Practice. Tan gives the following example of a counterpossible in scientific explanation. If diamond had not been covalently bonded, it would have been a better electrical conductor. Covalent bonds do not allow for free electrons, since all the electrons are used to form the bond, whereas other types of bonds leave free electrons. This allows the electrons to flow, a condition for electrical conductivity. And so this explains why diamond is a poor conductor. Certainly, scientists would not be inclined to accept if diamond had not been covalently bonded, it would not have been a better electrical conductor. It would have been a worse conductor. No, this would be judged false, right? If diamond had not been covalently bonded, it would have been a worse electrical conductor. That would be judged false. So these sorts of counterpossibles in certain scientific explanations, scientists seem to be presupposing that they are non-vacuous. Similarly, counterpossibles arise in the use of idealizations in science. For example, we might model a star as if it were composed of an ideal gas. An ideal gas consists of randomly moving point particles that are not subject to intermolecular friction. A point particle lacks spatial extension. As such, it may simply be impossible. But the notion of an ideal gas is useful because the way that some real gases behave approximates the behavior of an ideal gas in some contexts. So we reason with counterpossibles. We say, if the sun had been composed of an ideal gas, it would have behaved in such and such ways. This is useful because the actual behavior of the sun approximates how it would behave were it composed of an ideal gas. By modeling the sun as composed of an ideal gas, we significantly simplify the calculations with relatively little loss of empirical adequacy. But it's metaphysically impossible that the sun be composed of an ideal gas. So I guess the argument here is essentially something like this, right? So first, a philosophical theory of the semantics of some given type of statement should not entail that our best scientific theories are thoroughly in error with respect to that type of statement. Second, our best scientific theories treat some counterpossibles as non-vacuous. So, conclusion, philosophical theories of the semantics of counterpossibles should not entail that all counterpossibles are vacuous. So basically, this is just an application of a kind of naturalist epistemology that requires our philosophical theories to defer to the sciences. Now, there's a few questions about this here, I think. So, first of all, we might deny that science involves any ineliminable commitment to counterpossibles. Certainly we can frame some scientific explanations or some idealizations in scientific modeling in terms of counterpossibles, but it's not clear that we must do so. It's not clear that counterpossibles are ineliminable. It might be that these are just useful tools to communicate other kinds of information, as we saw could be argued with the Hobbes counterpossible. So when we say, for instance, if diamond had not been covalently bonded, it would have been a better electrical conductor. Perhaps what we are saying is, perhaps what's really being said is simply that diamond's poor electrical conductivity is grounded in the fact that it's covalently bonded. If that's all we're saying, then it looks like we're not committing to a counterpossible. Second, perhaps more importantly, we might wonder whether any of these are in fact counterpossibles. So take the diamond case, right? The antecedent is that diamond is not covalently bonded. Is this impossible? Well, if we think that diamond is what it is in virtue of its microphysical structure, right? If something is diamond only in virtue of its microphysical structure, then the antecedent does indeed describe an impossible situation. See my recent video on Putnam's twin earth argument for more on this kind of approach. But this is open to question, right? We might think that what makes something diamond is a matter of its, perhaps its manifest properties, its more observable properties. Or maybe we might just think that, there is no particular sort of essence of diamond. We might also think that it's possible for the laws of nature to have been different, and, in such a world, something that was not covalently bonded could have had the manifest properties associated with diamond, which is just to say it could have been diamond. So maybe actually diamonds not being covalently bonded is entirely possible. Similarly, in the case of the ideal gas, well, is it really impossible for there to be a particle that lacks spatial extension? There's no obvious inconsistency here. If that's impossible, what makes it impossible? In quantum mechanics, we already have a situation where particles have properties that would have been regarded as baffling to people from just a few hundred years ago. So we can't sort of maybe we find it strange, difficult to conceive of a point particle, but it's not quite the same. I mean, does that show that it's impossible, or is that maybe more just a limit of our imagination? But anyway, those were some of the motivations that favour non-vacuism. But if we endorse non-vacuism, well, what account should we give of the semantics of counterpossibles? As we've seen, the orthodox account entails vacuism, so this account will need to be modified. The most obvious option here is to appeal to impossible worlds. We have seen that according to the orthodox account, the counterfactual if P had been, Q would have been, is evaluated by considering the closest possible worlds at which P is true. This runs into trouble when P is impossible, because in that case there are no possible worlds at which P is true. So the simple fix is introduce impossible worlds, and then we say that a counterfactual is evaluated by considering the closest worlds at which P is true, where this may be a possible world or an impossible world. Where P is impossible, where we have a counterpossible, we consider only the impossible worlds. As with possible worlds, some impossible worlds are closer to the actual world than other impossible worlds. The trivial world, at which every proposition is true, is very distant from the actual world. The world in which the sun is a round square is closer but still distant. The world in which Hobbes successfully squares the circle is, as far as impossible worlds go, fairly close. So, with our Hobbes counterfactuals, the reason why H1 is false and H2 is true is that in the closest worlds in which Hobbes squares the circle, the children in Africa at the time do not care. So we make the minimal change required to verify the antecedent, and then we hold fixed all of the relevant other facts about society, geography, trade routes, and so on. So we just sort of straightforwardly apply this usual machinery of worlds in order to evaluate counterpossibles. Now, of course, if we introduce impossible worlds, we're going to need to give some account of what exactly they are. Modal realists like David Lewis treat possible worlds as concrete objects that exist just like our world. See my video on modal realism for more on that, which I'll link in the comments. It's unlikely that a modal realist would want to countenance concretely existing impossible worlds, right? For a Lewisian realist, for there to be an impossible world at which there is a round square would mean that there exists a round square, in the same way that there exists the Andromeda Galaxy. But there are other ways of thinking about what impossible worlds might be, and possible worlds more generally. So one popular view is that possible worlds are just sets of propositions that are maximal and consistent. So they're maximal in the sense that for every proposition, the set contains either that proposition or its negation. So the set gives us a complete description. It leaves nothing out. And they're consistent in that the set contains at most one of each contradictory pairs of propositions. A possible world is a maximal, consistent set of propositions. Now, on this way of thinking about what possible worlds are, impossible worlds do not present any metaphysical difficulties at all. An impossible world is just another set of propositions, presumably, maximal but inconsistent set of propositions. So I say, it's possible that there are talking donkeys. That is, there is a possible world at which there are talking donkeys. And this is to say that a maximal consistent set of propositions describes a talking donkey. In no sense does this commit us to the existence of talking donkeys. A set of propositions doesn't talk and is not a donkey, no more than a painting of a donkey talks or is a donkey. Similarly, then, it's impossible that there are round squares. So there is an impossible world at which there are round squares. That is to say, there's a maximal inconsistent set of propositions that describes a round square. In no sense does that commit us to the existence of round squares. A set of propositions is not round and is not square. Nothing is literally round or literally square here. So if we think of possible worlds as some sort of abstract entity, like sets of propositions, then impossible worlds, well, it doesn't look like they incur any greater ontological cost than possible worlds. Indeed, we don't really need to accept anything more than we already accept. If possible worlds are consistent sets of propositions, then of course we actually already have impossible worlds, because if we have propositions and we have sets of propositions, then we already have sets of propositions that are inconsistent. So yeah, certainly just in terms of the sort of pure metaphysics here, if we're thinking of possible worlds in terms of these like sets of propositions, it looks like impossible worlds do not introduce any difficulties. Now that's not to say that there are not plenty of other difficulties. So for instance, one difficulty is going to be, how do we evaluate the closeness of an impossible world? Well, even when we're dealing with possible worlds, that's a difficult question. Impossibility certainly does not make things easier. So, one thing we might wonder is, are all impossible worlds more distant than any possible world? Some philosophers have thought so. Daniel Nolan, for instance, says that all impossible worlds are more distant than any possible world. So, but then consider, for instance, the impossible world that is exactly like our world, except that it contains a box that is both empty and not empty. Right? Consider that world on the one hand. Now consider a possible world where this possible world has completely different physical laws, has only 2 dimensions, it comes into existence for 5 seconds, contains nothing but an image of a blue duck. Which is closer? The possible world or the impossible world? The impossible world is more like our world in terms of physical law, but its laws of logic are different. These are hard questions, and they do obviously complicate the theory. There's another technical worry here, which is that non-vacuism destroys the possibility of a logic of counterfactuals. So Korucek, in his article on Counterpossibles, considers the following case. So take what he calls the separation principle. So separation principle says, if Q and R would be the case were P the case, then Q would be the case were P the case, and R would be the case were P the case. So from the counterfactual, right, let's say I state a counterfactual, if P had been, Q and R would have been. Well, the separation principle tells us that from this counterfactual we can derive if P had been, Q would have been, and then also if P had been, R would have been. Well, that seems like a very simple principle of counterfactual reasoning. If anything counts as a principle of counterfactual reasoning, it would be this, surely. But now suppose that we are non-vacuists, right? And think about the following argument. If every instance of conjunction elimination had failed, both Ian and Barbara would have been sad. So, if every instance of conjunction elimination had failed, Ian would have been sad. Let's suppose that the premise here is true. Well, then presumably we can't accept the conclusion. We have to think that the conclusion is false, because, or at least the conclusion could have been false. The point is the inference from this premise to that conclusion employs the principle of conjunction elimination. But we're supposed to be imagining an impossible world in which conjunction elimination fails in every case. So in that world, right? So if we accept the premise here, right? If every instance of conjunction elimination had failed, both Ian and Barbara would be sad. Then we're going to have to say that this conclusion is false. That if every instance of conjunction elimination failed, Ian would have been sad, because yeah, we're considering an impossible world in which conjunction elimination fails in every case. So it now looks like we we can't make the inference from the premise to the conclusion. But in that case, we have a counterexample to the separation principle, because this argument is just an application of the separation principle. So the non-vacuist has to judge that this inference is invalid, but this inference is just an application of the separation principle. Obviously, under the supposition that every instance of conjunction elimination fails, we can't make an inference that employs conjunction elimination. So the separation principle has to be rejected. That's not going to hold universally. Now, the trouble is that similar examples could be constructed for pretty much any other principle of counterfactual reasoning you care to imagine. Just imagine an impossible world in which that principle fails in every case. Now, some philosophers have been happy to just embrace this consequence. Daniel Nolan, in his article on impossible worlds, just embraces this. So he grants that, yeah, if we make the antecedents sufficiently strange, we can cook up counterexamples to basically any proposed principle of counterfactual reasoning. So there can't be a logic of counterfactuals. There are no universal principles of counterfactual reasoning. There are a couple of points to keep in mind about this, though. So first of all, while there are no universal principles of counterfactual reasoning, it may be that there are principles that hold in more restricted contexts. So we can still say, for instance, that the separation principle is true of counterfactuals with possible antecedents. So maybe the separation principle only fails for counterpossibles, and maybe only for counterpossibles whose antecedents have certain, logical impossibilities, But so long as we're dealing with like ordinary counterfactuals whose antecedents are possible, we can proceed as if the separation principle were true. A second point is that, in general, we can, in practice, reason in the absence of any principles of formal logic, right? I mean, a lot of reasoning does not necessarily require applying the principles of some formal system. So even if there is no logic of counterfactuals, that wouldn't necessarily be an obstacle to reasoning with them. Okay, so before ending, I want to briefly note another option in this general debate. So we've seen that vacuists accept the orthodox possible worlds account of counterfactuals and conclude that all counterpossibles are trivial. Non-vacuists say that there are non-trivial counterpossibles, so they conclude that the orthodox account needs modification. But another option is to say that, strictly speaking, there are no counterpossibles anyway. The proposed examples to the orthodox account are not vacuous, but they're also not genuine counterexamples, because they're not counterpossibles. So, on this view, nothing is impossible. This view is called possibilism. It's been defended by Chris Mortensen in his article, Anything is Possible. So we saw this in the case of proposed counterpossibles in science, right? When I model the sun as if it were an ideal gas, am I describing an impossible situation? Is an ideal gas impossible? The ideal gas is composed of point particles. Well, maybe that's impossible given the actual physical laws, but then why shouldn't there be alternative physical laws which allow for point particles? Maybe it's possible, absolutely possible, for the laws of nature to have been different. And this is the case according to the possibilist. According to the possibilist, nothing is absolutely impossible. We can talk about impossibilities in restricted domains, right? So I can say, for instance, it's impossible to accelerate beyond the speed of light. But what I'm doing there is saying that something is ruled out by physical law. Right, so when I say that it's impossible to accelerate beyond the speed of light, context will usually fix that I'm specifying the domain of worlds with the same physical laws. But speaking unrestrictedly, the physical laws could have been different. Similarly, I might say that it's impossible for both P and not P to be true. True contradictions are ruled out by the logical laws. But speaking unrestrictedly, the laws of logic could have been different. So while we distinguish the possible from the impossible, that's always going to be relative to some domain, relative to some context of assessment. If we speak unrestrictedly, there is no impossibility. There is nothing that is absolutely ruled out. So if you take this sort of view, then you're going to say, well, there are no counterpossibles. So we can apply the standard semantics, the standard possible worlds framework to all counterfactuals, and we get results that are consistent with our intuitions. Now, of course, this view still has plenty of drawbacks. I mean, it's consistent with our intuitions about certain counterpossible statements, but it's still, probably not consistent with our intuitions in other respects. To say, for instance, that the laws of logic could have been different. And of course, it also destroys the possibility of a logic of counterfactuals for the same reason that non-vacuism does. So, this position has its drawbacks as well. But okay, that's all I wanted to talk about today. So thank you for watching. I'll see you next time. Bye, everybody.